Alright, let's get to part 2 of our immune system discussion. Remember that slide talked about the major histocompatibility complex that is important to have cells be recognizable as self, if that is bound with a fragment of our own cell. If the major histocompatibility complex is bound to a fragment of somebody else, an antigen, there to speak, then we have a problem. And so this section now goes into what happens after that. So specific immunity is always directed to one specific invader. And the antigen is the part of that invader that we recognize and we can attack. And that invader has to be previously encountered. So we have to have learned who that is, what does it look like, so we can have the proper response to it. Specific immune cells need to learn to recognize what the MHC is, the major histocompatibility complex, because it has to be it's a very, very fine line between attacking self and non-self. It's very delicate that we know what self looks like. And so the T cells learn the MHC recognition in the thymus. That's why they're called T cells, for thymus. And they mature there, and then after that they're sent to secondary lymphoid organs, which is where they live in. And some of that is lymph nodes, for example. The B cells undergo the same maturation process, but they do that in the bone marrow, not in the red bone marrow. That's bone marrow for B cell. So, T helper cells. So the T cells come in multiples. They come in T helper cells, they come in T killer cells, and they also come in T suppressor cells. The T helper cells, they help. They have a receptor for a specific antigen, and they are activated when they bind to the corresponding MHC/antigen complex on an antigen presenting cell. Remember, that's a cell that has been a macrophage that has eaten one of those one of those foreign invaders, and presents their antigen on the surface combined with the MHC. So that's then the molecular alarm saying, hello, we got a problem. Then activated T helper cells will do a few things. They bind to the B cells that show also the same MHC antigen fragment. So that will help us understand it's the same, we're going to work for the same invader, because all those cells are very specific. The B cells and the T cells are very specific. So then the B cells are activated through that, and then the B cells interleukins, the T cells interleukins, so the little hormones that the T cell will secrete after they combine together, will then help proliferate the B cells that are specialized to produce antibodies. So those are, we call them plasma B cells, and they will secrete many, many antibodies in rapid rates that then will swarm around in the system to neutralize the antigen. And we got a slide on that of how they do that. And that is then part of that humoral immunity, those antigens floating around, because at that point they are not cells, they're just protein fragments. We have T suppressor cells, and they diminish an immune reaction by secreting, again, small little localized acting hormones called cytokines that suppress both the B cell and the T cell activity. And this will wind down the immune response after the antigen has been inactivated, preventing unnecessary immune system activity. If that doesn't work right, we will have autoimmune reactions, and that's when the immune system attacks oneself. The T killer cells, or the cytotoxic cells, are the sharpshooter in the system, and they destroy infected or degenerated cells by direct contact. What they do is they are activated by the T helper cells, and then they know who to go for, and they have little perforants, little bullets, similar to a gun bullet, that will shoot those infected cells down, and when they get holes into their boundary, their cell membrane, they will disintegrate. this is, we already looked at that briefly when we discussed the natural killer cells, or when I mentioned the natural killer cells. B lymphocytes have antibodies attached to the surface, and when a corresponding antigen binds to them, the cell ingests the antibody and the antigen complex, and then it will present that to the surface, which is what I've mentioned previously. That is what activates, or that is what then combines with an activated T helper cells, and when both the activated T helper and the activated B plasma cell combine, then we are ready to make many antibodies and proliferate them greatly, and therefore try to render that invader harmless as fast as possible. So here's what the antibodies do. They function to neutralize specific antigens by tagging them, as well as causing them to cross-link into large complexes that will settle out in solution, which is precipitation. They also activate a complement system, which goes and destroys the cells by making holes into them, by just creating big holes that destroy the boundary. Some activated B and T cells are transformed to memory cells that live in lymphoid tissue until they encounter a specific antigen again. And this is really what makes it be a specific learned immunity, because we have memory cells that are right there standing by to be just producing stuff immediately. So at that point, they're ready and can react more rapidly and effectively to a new contact, and that is the secondary immune response. When we look at immunization, or active immunization occurs when the organism itself forms the antibodies. Besides exposure, so that's when the body makes its work, body makes antibodies. And so this can be done by exposure, like, you know, the kids used to go to the neighbors when there was a chickenpox outbreak. Or it can also be achieved artificially by introducing an attenuated, non-pathogenic agent. Meaning, it's a vaccine, basically, but meaning it's an agent that has a shell that makes your immune system get activated, but it doesn't have the properties to make your body react with fever and all that kind of stuff and make you sick. And so that helps then when we have a secondary exposure. The immune system is ready without even having had the first proper full-fledged disease-producing exposure. So that's active immunity, either natural, by getting sick and then being primed, or having it done by a needle and a vaccine. Well, sometimes it's oral. Then we have passive immunity, and passive immunity can be achieved when ready-made antibodies are administered. So the body does not do the production of the antibodies, the body just receives antibodies. For example, when a mother passes antibodies naturally through the breast milk, that's a natural passive immunity. This is one example or one reason why you want to breastfeed, because if a milk is made somewhere else, that milk doesn't have antibodies for the region that we are living in. But a mother always is around the child, or at least supposed to, or more common than not. And so that body is exposed to the same kind of antigens that the baby is exposed to. And so the mother's milk carries antibodies to protect the baby until the baby's immune system is strong enough to make its own. We can also have this passive immunity administered artificially, and that's, for example, when we get an anti-venom injection after a snake bite. And so we have that, then we just squirt antibodies that go for that snake bite into the system, because the system, well, if it's a bad snake, it will not survive the attack.